Unit 6, Example 7, AP Statistics. Babies. Okay, here we go. So, while only 5% of babies have learned to walk by the age of 10 months, 75% are walking by 13 months. So, in the span of 3 months, we go from 5% to 75%. That's huge. So, if the age at which babies develop the ability to walk can be described by a normal model, find the population parameters. So, this problem is a little different, a little more challenging. So, in other words, you're finding the mean and standard deviation. You are finding now what goes into the parameters. All right, so let's start by drawing a picture. That will make this a little bit easier. All right, so we don't know what the mean is because that's what we're being tasked to find. So I do know that along the x-axis, though, I'm going to have months because if I'm looking at the normal parameters, I'm going to have an average amount of months at which babies start walking, and then I'm going to have a standard deviation. So along the x-axis, that is where I'm going to have I'm going to put 10 months and I'm going to put 13 months, but I've got to figure out where they go. So let's think about this. 5% of babies walk at 10 months, and then 75% are walking by 13 months. So if this whole curve represents 1, 5% is not very much of it, and 75% is a lot of it. So it would stand to reason that the 10 months would be below the mean, somewhere over here. And that this is going to represent 5%. And then somewhere to the right, I'm going to have 13 months, and that would mean everything to the left of 13 would be 75%, because by the time we get to 13 months, 75% of the babies are walking. So this is going to represent 0.25 to the right of 13 months. Okay, so let's look at what we have going here. This is a span of 3 months. So in a 3-month time period, we go from 5% to 75% walking. So there's a couple of different ways you can do this. I just gave you a visual here so you could see what was happening. One way is really easy, and the other way is a little more challenging depending on how your brain works. One of them is very algebraic, one of them is somewhat algebraic. So if you do it this way, if you do it the more difficult way, that means you're going to need to find your z-scores. So we've got to figure out then what our areas would be at these specific values so that we can calculate a z-score. So if we use our chart, we're going to use our chart to look up the area at 5%. That will give me my z-score at 10 months. And I'm going to then also find the area, or find the z-score at 75%, because that will give me the z-score over here. So if I look at my chart, okay, if I'm looking at 5%, and this is going to be in the negative values because it's below the mean, it would help to go the right way. I should have erased all this stuff. Sorry, kids. Okay, so 0.05. What's the closest one to 0.05? Okay, we've got 0.05 here, or this is pretty close. Doesn't really matter which one you pick because they're both the same distance away from 0.05. So if we choose negative 1.64 for that one, and then at 75%, this one's going to be a positive value. So the one closest to 75% we've got this one. Okay, 0.7486, it's closer to 0.75 than this one right here. So we're going to go with 0.67. Okay, now what we have to think about at this point, we have to think about the idea of getting our mean and standard deviation from this. So I am going to use this z-score in my z-score formula because I know at 13 months my z-score would be 0.67. So 13 minus mu, which I don't know, over the standard deviation. So I need to know what the standard deviation is. So let's think about this just a little. All right, so if I look at my two z-scores that I have, and let's just add those together because they represent distance away from the mean. So 1.64 plus 0.67 is going to give me 2.31 standard deviations. So what does that tell me? Well, that tells me that in this 3-month area here, okay, it tells me that this distance and this distance, which would be these two things right here, is representative of 3 months. So on just as an estimate, I know that 3 months is equal to 2.31 standard deviations. All right, so now all I have to do is divide by 2.31, and I get an estimate for my standard deviation of 1.299. All right, now what I can do is use that right here and now I can do some fancy math. And I can find my mean that way. Okay, and I don't have my calculator with me, so just trust me. Okay, so that gives me my parameters right there, 12.13 and a standard deviation of 1.299. Now, if you like to problem solve and this speaks to you, you're going to love doing this problem this way. There is another way to do it, and it is algebraically heavy. So what does it look like, Miss Griggs? Well, I'm going to have to scroll down here to where I have more room. Oh, there is no more room. Okay. All right, so here's the algebraic way. If you're happy with that way, stop the video. All right, so here's the deal. I've got my picture here, and I've got 10 months over here and 13 months over here. So I already found the z-scores. You're going to need to do that regardless because you got to have something. So this z-score was 0.67. So what I'm going to do is I'm going to set up two algebraic problems. I'm going to set up my z-score formula for both of these. All right, so I've got negative 1.64 here, 10 minus mu over the standard deviation. And then I'm just going to cross multiply, so I've got negative 1.64 standard deviations equals 10 minus mu. And then I'm going to subtract 10 from both sides. And I am going to divide everything by a negative 1 because I don't want negative mu. Okay, so this mean is equal to 1.64 standard deviations plus 10. All right, so now I'm going to do the exact same thing for the other equation. So I've got 0.67, which equals 13 minus mu over the standard deviation. I'm going to cross multiply again. Subtract 13 from both sides. Divide everything by a negative 1. And again, I have an equation for mu. All right, algebra's beautiful. I want you to notice something. Oh, I didn't write a plus here. I want you to notice something. Mu equals this and mu equals that. That indicates to me that I can set those equal to each other. So 1.64 standard deviations plus 10 equals negative 0.67 standard deviations plus 13. Beautiful. Okay, so what I'm going to do is I am going to add 0.67 standard deviations to both sides. And I get 2.31 standard deviations plus 10 equals 13. Then I'm going to subtract 10 from both sides, blah, blah, blah. That equals 3. Divide by 2.31. And you get 1.29. And then you can use that in one of your equations. It does not matter which one. To get the mu, or the mean. And then, of course, you have your parameters. Good luck.